This problem is about humming into a well. It says, a person hums into the top of a well and finds that standing waves are established at frequencies of 42, 70.0, and 98 Hz. The frequency of 42 Hz is not necessarily the fundamental frequency. The speed of sound is 343 meters per second. How deep is the well? I just figured I'm going to take a cowboy who is going to hum into the well, even though he's probably going to be smarter to figure out what the depth of the well is rather than using waves and sound and trying to make a measurement. And so, as I said, he's probably going to figure it out in a different way, probably a quicker way too. And then, of course, the thing is, how do you actually get a sound wave in there and measure it? Well, you probably have a loudspeaker there that you can adjust the frequency, and then you have a microphone that receives it, and you figure out, oh, these are standing waves. So anyway, that's how it's being done. So let's see again what do they give us here. So they're going to give us f equals 42 hertz, and then they're going to give us f equals 70.0 hertz. For some reason they throw in a 3 significant figure data point, and then f equals 98 hertz. And none of these are labeled because they explicitly say that 42 is not necessarily fundamental frequency. Speed of sound, as usual, is 343 meters per second. The well itself is kind of like a tube that's open at the top and closed at the bottom because that's where the water is sitting. So that's where we're going to use a tube open at only one end. And oh yeah, I should write down what they're asking for, which is the depth of the well. I could write that as D or H or something. I'm going to write it as H here for just a moment. But as far as the tube is concerned, that is usually written in this chapter as length L, so that height or depth inside the well is the same as L. That lands the equation for a tube open at only one end, where it says Fn equals n, n meaning the number of the harmonic, and maybe I can write this a little nicer, n, there we go, times V over 4L. There we go. That is supposed to be a 4, and this is supposed to be an L. And we're supposed to figure out what L is. However, we don't know that little n here, so we don't know this n here either, because it says, hey, this is not a fundamental one, and let's see what we get here. Now, any one of these are harmonics of the fundamental frequency, so therefore there is a certain ratio between these three. We can establish three different ratios. We can say, I'll use a different color, we can say that there is a ratio between the 70 and the 42. There is a ratio between the 98 and the 70, and there's a ratio between the 98 and 42. And when we reduce those, we divide this one here by 7, which is 10, and we divide this one by 7, which is 6, and so we have 10 over 6, and actually we have 5 over 3. That is already enough information, but let's just go on. This one is also divisible by 7, so that's 14 divided by 10, respectively 7 divided by 5, and again this one is divided by 7 is 14 over 6, so that's 7 over 3, and we can see, okay, the 3 is associated with the 42 over here as well, the 5 with the 70 over here as well, and the 98 is associated with the 7, and that tells us that this one is the 3rd harmonic, and this one is the 5th harmonic, and this one is the 7th harmonic. And technically we only need one ratio here, but they gave us the 3rd number, so we can check against that is indeed the case at all times. So at this point here, we can just say, I'm going to change the color again. We could, for example, choose the 98 hertz, and then we would say F7 equals 7 times V over 4L. Respectively, we're supposed to come up with L. So L equals, let's see, 7 times V divided by 4 times F7. Everything is in base units or standard units, so we're going to come up with the standard unit for the length L, or the depth of the well, in meters. Once you get the answer, you'll actually see that the well is really not that deep, that you could actually shine a flashlight in there and kind of estimate what the depth is, and you wouldn't even have to go through to that length. But then again, it's a perfectly fine physics problem on waves inside a tube that is open at only one end.